In this example, we're going to determine the equation of a periodic function shown where there's more than one cycle of the periodic function. So when we do a question like this, we have choices. Which parent function do we want to use? I often use positive cos x because for me, positive cos x is rather easy to see. We go from the maximum to the maximum, and we focus on just that one cycle. So focusing on just that one cycle, we see that we're going to say the parent function is y equals cos x, and then we're going to be able to, from there, determine the d value. Well, for us, the phase shift is equal to 2 squares, which is 6 pi due to the scale of the x-axis being 3 pi. And then we're going to see that the period is going to be equal to 4 squares. Each one of those squares has a scale of 3 pi, so the period is going to be 12 pi, making the k value be 2 pi over that value. The pi's cancel out. 2 over 12 is equal to 1 over 6. The axis of symmetry is going to be along this horizontal line right here. On first glance, that might look like y equals -1. It's actually y equals -5 because you pay attention to the scale on the y-axis. The scale on the y-axis says each one of those vertical squares equals 5. If there's no scale shown, you assume it to be 1. But in this case, it's shown, so we want to make note of that. Now, we can say c is equal to -5 just by observation. If you don't like doing that, then what you can do is you can say c is equal to the maximum value, the maximum y value, which is +10, plus the minimum y value, which is -20, all over 2. 10 minus 20, quantity divided by 2, is equal to -5. And we can say that the amplitude is equal to +15. By observation, you can see that the amplitude is equal to 3 vertical squares. And so each vertical square is -15. So you don't have to show any work for that. But if you want to show some work, it's always equal to the maximum y value minus the minimum y value, all over 2. 30 over 2 is equal to 15. Since we are using a positive cos x curve, the a value will equal the amplitude. So the a value in this case is going to be 15, and we can state the equation of our curve. Y equals 15 cos 1/6 x minus 6 pi plus 15. Now, if we had wanted to, instead of saying x minus 6 pi, we actually could have said that our cycle for cos is going to start here, and we're going to focus on this cycle. That would have been just as adequate. And if we had done that, everything in this equation would have stayed the same. The only difference would have been that instead of saying our d value was 6 pi, 2 squares in, our d value would have been 18 pi, which is 6 squares in. So if we wanted to, we could just change this 6 pi to an 18 pi, and that would also be adequate. Or, believe it or not, if we wanted to, we could keep the symmetry of this curve going. And we could say, this is looking pretty sloppy, but we could focus on this cycle of the cos curve, the one I'm drawing in right now. And had we done that, everything would have stayed the same, except our phase shift would have been 2 squares to the left of the y-axis. So instead of being a phase shift of +6 pi, it would have been a phase shift of -6 pi, and that would have made the interior, this bracket here, x plus 6 pi. So all of those would have been valid answers. And so the point I'm trying to make there is there's always going to be more than one answer to any one of these questions. And in fact, you might say, well, what if we didn't use positive cos x as our parent? Well, instead of using positive cos x as our parent, what if we had used negative cos x as our parent? And the answer is, that's fine. If we had chosen to use negative cos x as our parent, our amplitude still would have been 15, but because we're using negative cos x, A would have been negative 15. And our D value, our K value still would have been 1/6 because we would have had the same period. Our phase shift would have changed, so we could have said it's x minus 4 squares in would have been 12 pi, x minus 12 pi, plus, and our C value still would have been -5, so we would have had a -5 there. And that would be a totally accurate way of looking at this curve. And in fact, if we really wanted to get cheeky, we could have said, you know what, let's focus on this cycle. So we would have created half of the cycle just by going by the symmetry of it. And focusing only on this half a cycle, we could have said that the equation is -15 cos 1/6 x minus 5, because there would have been no phase shift whatsoever, because if you follow the symmetry, letting every period be four squares wide, in other words 12 pi radians, if you follow that symmetry and then draw a cycle back, you see that a cycle of negative cos begins right at an x value of 0. So we could have said that was the equation, and both of those would have been equally valid answers. And you might say, well, what do we have against sine x? And the answer is nothing whatsoever. We could have said that we had a sine curve right there, and keeping the phase shift, changing the phase shift, but keeping all the other information the same, we could have said that the equation of the curve was 15 sine 1/6 x minus, this is 5 horizontal squares in, so we would have said x minus 5 squares would have been 15 pi minus 5, and that would have been a valid answer. Or we could have, believe it or not, just brought this back just a little bit, kept the symmetry the same, and focusing only on this cycle, the one that I'm sort of shading in here in a funny way, focusing only on that cycle, we could have said that we have the curve 15 sine 1/6 x minus 3 pi minus 5. So you might be saying, how do we know which one to use? And the answer is they're all valid. Unless there's something specific in the question, these are all valid. Or, you know what the heck, we could have used a negative sine curve. And had we done that, we would have simply changed the phase shift, but the amplitude still would have been -15, and we would have had -15 sine 1/6 x minus 9 pi plus c, which would have been -5. So you see that in every one of these cases, depending on what our parent function is, what it does is it changes the phase shift, and it might change the a value from positive to negative, but really we see that there's multiple answers possible in every one of these situations, and they're all equally valid. Personally, I prefer, when I have a question like this, to look at it as a positive cos curve or a negative cos curve, because I generally see those cycles more easily than I see the other ones. But whichever you use is fine, so long as there's nothing in the question saying that you needed to do it a certain way.